Welcome back, student. Today we will go to the topics glycosidic bond, structure of disaccharides, formation which are formed by combination of monosaccharides, and there are some properties, reducing and non-reducing properties, and structure of polysaccharides. In the earlier classes, we have already studied about the basic information of carbohydrates, its importance, its classifications, and structure of glucose and fructose kind of monosaccharides. So let us go to the glycosidic bond. Glycosidic bond or glycosidic linkage is formed between the hemiacetal or hemiketal group of a saccharide and hydroxyl group of some compounds such as alcohol, saccharide, etc. For example, this is the glucose molecule where this is the anomeric carbon. Okay, hemiacetal or hemiketal group of saccharide means this anomeric carbon containing the OH group. This OH group is termed as hemiacetal or hemiketal. Why? This after decyclization of this structure, this OH group get transformed into aldehyde or ketone. That's why this OH group is termed as hemiacetal or hemiketal. Okay, so here in the glucose, this is hemiacetal group. So this hemiacetal group reacts with the alcoholic part of the hydroxyl part of the alcohol to form a bond with the release to form a ether kind of bond with the release of one water molecule. This ether kind of bond is termed as the glycosidic bond. Okay, the glycosidic bond is the formation of bond between the hemiacetal group and the hydroxyl group of alcohol or saccharide. So let us take some other examples. Sucrose. Sucrose has two sugar unit, or we can say two monosaccharide unit. One is glucose, other one is fructose. Here glucose hemiacetal group combines with the hydroxyl group of fructose present in fructose, leading to the formation of glycosidic linkage. Again, in this molecule maltose, two glucose unit combine where the hemiacetal group OH group present in carbon 1 reacts with the OH group present in carbon number 4, leading to the formation of carbon 1 carbon 4 glycosidic linkage. Okay, so let us take examples of disaccharides. So with this we will able to learn about the structure of disaccharides also. So let us take example sucrose. Sucrose, we know that it will produce glucose and fructose, two monosaccharides on hydrolysis. That means it contains glucose and fructose monosaccharide. Or we can say glucose and fructose combine to form sucrose. So how it is formed, let us see. How the glycosidic bond is formed between glucose and fructose. So here alpha glucose, where hemiacetal group of glucose reacts with the hydroxyl group present in beta fructose. So after removal of this water molecule, here it is shown in the circular manner, this water molecule removes to lead to the formation of the glycosidic linkage and hence the sucrose molecule. So here we have seen that the hydroxyl group of glucose, here it is hemiacetyl hydroxyl group, and here in the fructose molecule it is the hemiketyl hydroxyl group. So hemiketyl and hemiacetyl both are get engaged in the formation of the glycosidic linkage. So that's why it is unable to reduce the Fehling solution. So that's why it is also termed as non-reducing sugar. Again, if we see the activity, optical activity of sucrose, it has the optical activity, positive optical activity. That means that it is dextrorotatory. But after hydrolysis, we know that after hydrolysis it get converted to glucose and fructose. Glucose in its pure form shows the optical activity plus 52.5 degree, while fructose in its pure form in solution it shows minus 92.4 degree. That means it is levorotatory. Glucose is dextrorotatory, fructose is much more levorotatory. So combination of this in the solution will result in levorotatory solution. So usually without hydrolysis, if hydrolysis is not happening, then sucrose will act as a dextrorotatory solution. Sucrose in solution behaves as dextrorotatory. But when hydrolysis occur, formation of fructose and glucose results in the mixture which is behaves now levorotatory. Thus, hydrolysis of sucrose brings about a change in the sign of rotation, optical activity rotation. So this that's why sucrose is termed as invert sugar. Usually it is dextrorotatory, but after hydrolysis the solution becomes levorotatory. That's why it is termed as invert sugar. Next, maltose. Maltose is composed of two glucose unit. So here the two glucose unit, how they combine? In one glucose unit, one hemiacetyl group combined with the hemiacetyl group of one glucose unit combined to the hydroxyl group present in the carbon 4, leading to the formation of glycosidic linkage. In this molecule, maltose molecule, the C1 end of another unit remains free to reduce the Fehling solution. So that's why this maltose molecule is a reducing sugar, but sucrose is not, since the hemiacetyl and hemiketyl group both are engaged in the formation of the glycosidic linkage. Next, lactose. Lactose is a milk sugar. The glycosidic bond formed between the galactose and glucose, it is between the hemiacetyl and the hydroxyl group present in the carbon 4. So here the glycosidic linkage formed is between the hemiacetyl of the galactose and the hydroxyl group present at the carbon 4. So in this case also the hemiacetyl group of glucose unit remains free to reduce the Fehling solution or tolerance free agent. So that's why it is also termed as, it is also acts as reducing sugar. Let us see the structures of polysaccharides now. Polysaccharides, already we have known it is a class of carbohydrate which releases a large number of monosaccharide units on hydrolysis. This definition can also be reframed as that polysaccharides contain large number of monosaccharide units joined together by glycosidic linkage. Since we are know about the glycosidic linkage, we can reframe the definition in this way also. So, polysaccharide molecules are the large carbohydrate molecules. They are complex one. They mainly act as the food storage or structural material. For example, starch, cellulose, glycogen, etc. So let us start with the starch molecule. Starch is the main storage polysaccharide of plants. It is the most important dietary source for human beings. High content of starch is found in cereals, roots, tubers, and some vegetables. It is a polymer of alpha glucose and it consists of two components, amylose and amylopectin. So what is amylose? Amylose is water soluble component which constitute about 15 to 20% of starch, and amylopectin is insoluble part of the starch molecule, insoluble in which is insoluble in water, and it constitute about 80 to 85% of starch. It is a long unbranched chain in case of amylose, while amylopectin are branched chain polymer. Amylose contains 200 to 1000 alpha glucose unit, while amylopectin contains alpha D glucose units in which a chain is formed by C1-C4 glycosidic linkage, whereas branching occurs at C1 and C6 glycosidic linkage. In case of amylose, the glycosidic linkage formed between the C1 and C4 only. So these are the structures amylose, where we have seen that here carbon 1 and carbon 4 has been involved in formation of the glycosidic linkage in case of amylose. In case of amylopectin, two kinds of glycosidic linkage are formed. One is between C1 and C4 and one is between C1 and C6. So amylopectin is a branched polymer and amylose is a long chain polymer. Let us take another example, cellulose, which is a again polysaccharide. Here the glucose units combine through C1 and C4 unit. Here, in case of cellulose, the glucose unit is present in the beta form. So beta D glucose units are combined through C1 and C4 glycosidic linkage, and that's why these bonds are also termed as beta glycosidic linkage. In case of starch, all are alpha glycosidic linkage. Glycogen is the carbohydrate molecule which are stored in animal body. It is also known as animal starch because its structure is similar to amylopectin and is rather more highly branched. It is present in liver, muscles, and brain. When the body needs glucose, enzymes break the glycogen down to glucose, and this glycogen is also found in yeast and fungi. So these are the references whichever I have followed. You can go through these references also. Thank you.